The next use case that we're going to talk of is what we call as insider attacks. And in order to illustrate this, typically insider attacks are initiated by, like I mentioned, inadvertent insiders are colluding with hackers from the outside or perhaps disgruntled employees. So the use case that we're going to speak of is a scheduled time bomb. A time bomb is a piece of malicious code that executes when a specific trigger condition is met. A typical example would be that a program monitors a company's payroll system and attacks the company if a specific employee is terminated. A time bomb is a type of logic time bomb that uses date and time as its triggering function, meaning when the date is met or the time bomb is detonated from the inside, it might crash your application by performing either a denial of service, or it might potentially delete critical data or degrade the response time of your system. So let us walk through this code base that contains all the symptoms of the time bomb. We'll use the same example, tar pit in this case. And as we examine this piece of code, there is a time bomb embedded in this code that triggers if a timed condition is met. So as a part of this workflow, let us draw attention to this function called as ticking. Ticking takes two calendars instances into consideration, and it compares the current time to the future time. And if that condition is met, it effectively executes a command, which is this exec pattern. And if I traverse to this exec pattern is effectively a base 64 encoded pattern. So it's very hard to guess what this exec pattern could be if you are effectively doing code reviews, because it's base 64 encoded. It's hidden from the eye of your code reviewer. So let us examine how we can identify this condition using Ocular. So I'm going to ask a few questions. First of all, is any engineer using runtime.getRuntime.exec function? This is often a bad code pattern, which could raise suspicion of whether there is a potential time bomb in your application. So obviously, yes, we got back a response that the ticking function is using runtime.getRuntime. Now, let us further ask if any input can influence this function. For that, I'm going to ask the full name of the method ticking, which accepts an input, which is a string that influences this particular execution path. I'm going to mark the runtime.getRuntime as a sink, and thereafter I'm going to conduct reachability to identify if a source can touch a sink in this case. Obviously, yes, we got back a response that indicates that a parameter injected, which is a time function influencing the calendar, is causing this method to trigger the runtime.getRuntime. So this is the first condition that exists in the code that proves that a potential time bomb condition exists in this function. The next inquiry that we're going to conduct is whether there are any calendar instances being compared within the scope of this function ticking. And for this, I'm going to first check whether the calendar function set is being called in this function. For this, I'm going to, again, call upon this Fluent API, which is CPG method full name caller. And yes, I've identified that the ticking function is using a calendar set. Again, the next call is to mark or assign the calendar set function to a source and check to see if there's a comparator, which is calendar after being executed based on the source input received. Thereafter, we conduct reachability analysis, meaning is a calendar instance being initialized and influencing this comparator? So obviously, yes, we got back a stack trace, which indicates that we have a calendar function being initialized. So based on this, it's obvious that first of all, we have runtime.getRuntime in this code, which we identified using the flow, which is influenced by the input. And we have a calendar comparator being conducted within the scope of this function, which are the two symptoms that essentially leads to the fact that there is a time bomb executed within the scope of this function.